Okay, so we're gonna do the third example today, but it's the second RC. This is a little bit trickier because there's a function here, u of t minus 1, and this is a 1 amp power supply. So instead of just following the usual less than 0 and after t equals 0, we're going to do for t less than 0, and I just did this in the previous video. There is no power supply turned on, the capacitor is not charged, the voltage across the capacitor until time equals 0 is 0 volts. At 0, this turns on, but this one only turns on at 1, at t equals 1. So now I'm going to do only between 0 and 1 seconds, and the circuit is 2 ohms, 8 ohms, in the 3 amp power supply. We also just solved this by finding R to be 10 and tau to be 1 second because it's 10 times 0.1. We also found the voltage across the capacitor for t tending to infinity for this circuit. It's a in principle infinity here, to be 24 volts because it's 3 times 8, 24, and we wrote the final equation only for this part without considering this one to be Vc of t 24 1 minus e to the minus t volts. This, in this case, is only valid until t equals 1. So at t equals 1, Vc of 1 will be 24 minus 24 times 1 minus 1 over e. And this comes out to be around 15 volts. 15 point something. I did that the other day. 15.2, 15.17 volts. So at t equals 1, I know the capacitor has 15 volts. And now I use this as the starting point for my next circuit. So for t larger than 1, oopsie, I have this circuit and this power supply kicks in. So then I have 1 amp going up, 2 ohms, 8 ohms, and 3 amps going down. And the capacitor is here in the middle. 2, 8, 3 amps. And then I do the same exact thing, right? So the resistance that the capacitor sees is still 10 ohms. The capacitor is still 0.1. So tau is still 1 second. The catch is, what is the voltage across the capacitor for t tending to infinity? And in this case, it is truly for t at that time. This one, really, we were interested in that just so that we could write this equation. Here, the capacitor acts as an open. So this is the circuit that I'm looking at. 3, 1, 2, 8. So there's 1 amp going down here. Because there's 1 amp going down, there's 2 volts here. And here there's 3 amps going up, which means there's 24 in this direction. So if I put ground here, this nodal voltage is plus 2. If I put ground here, this nodal voltage is minus 24. If I put ground here, the voltage across the capacitor here will be 2 minus 24, which is 26 volts. This is what I will use again in the solution, assuming that the original, the initial voltage across the capacitor is 15.2. So, for t less than 1, Vc of t is the 24, 1 minus e to the minus t volts. For t larger than 1, Vc of t will be 26 plus what was at 0, which was 15.2, the 0 here, sorry. What voltage across capacitor was at t equals 1? Minus 26 e to the minus t volts. So here you could say it's minus Vc of t is 26 minus 10.8 e to the minus t volts. So this is only valid from 1 or after 1 second. This is valid. I mean, both of them should be the same at 1. And for t less than 0, it should be 0 volts across the capacitor. So this would have been the answer. 2 lines.